Hello geometry students, and welcome to chapter 9, all about right triangles, though we will get into oblique non-right triangles as well. And it will be your introduction to trigonometry. This is a pretty important chapter. It's going to lay the foundation that's going to be built on for the next couple of math courses that you will probably take. But we're going to start off really friendly with the Pythagorean theorem, which hopefully you've all seen before. So in a right triangle, you have a leg, you have two legs, and you have a hypotenuse. The hypotenuse is always going to be opposite the right angle. And in general, sometimes we label these with letters, so I'll call this one A, this one B, and our hypotenuse C. So the Pythagorean theorem is something, it's a formula that describes the relationship of those three sides to the triangle. I can't write and talk, sorry. A formula that describes the relationship of the three sides. So given any two sides, you can find the third. And that formula, which you all know and love, a squared plus b squared equals c squared. But remember, a, b, and c are just random variables. So really what's going on is it's a leg squared plus the leg squared equals the hypotenuse squared. And again, sometimes the hypotenuse will be one of the knowns, so you want to make sure it's going to be in that relationship, all right? Now, because we all are familiar with this Pythagorean theorem, one thing you may not know, and this is based on similarity, where and our transformations, if I have a particular right triangle, I can blow the sides up proportionally, and what we get are called Pythagorean triples. And these are really handy to kind of get to know. So let's start with this first one. This one we know we have 3 and 4 for the sides. So we have 3 squared plus 4 squared, so that equals 9 plus 16, which is 25. Now, in order to find c, we have to take the square root of that, because c squared is 25. So we take the square root, and we know that c is going to be 5. So this is what we call a 3, 4, 5 right triangle, where the longest side is always your hypotenuse. Well, it turns out that if I were to put this in a Xerox machine and blow it up, that you would also have a 6, 8, 10. So that would be multiplying all your sides by 2. It would still be proportional. Or I could multiply all sides by 3. That would give me a 9, 12, 15. But the family is this first one. It's a 3, 4, 5, and all multiples of 3, 4, 5. Okay, so that's a very common family to get to know. And what's helpful about is if you know your triples, you don't necessarily have to do Pythagorean theorem because you know it'll be part of that. All right, in this next one, we are given a hypotenuse and a side. So I know that a squared plus 15 squared equals 17 squared. To solve for a squared, we have to subtract. So 17 squared minus 15 squared, that's going to give you 64. So that means a is going to be 8. So this family is called an 8, 15, 17 family. That's sort of the parent of that family. And again, any multiple. So if I saw 16, 30, 34, that would also be a right triangle, and it would also be a Pythagorean triple. I could triple that and get 24, 45. This isn't quite as common, but sometimes you'll recognize it. So again, any multiple of 8, 15, 17 will also give you a right triangle. Now this next one, we have 5 and we have 12. So I know that 5 squared plus 12 squared, 25 plus 144 is 169. And so if I take the square root of that, I get that my C value is going to be 13. So this family is what we call a 5, 12, 13 family. It's also very common. And any multiple of that. So I could double all the sides, 10, 24, 26. That's also quite common. I could triple all the sides, so I'd have 15, 36, 39, etc. Any multiple or even division of that, quotient of that. I'm not quite sure what the right word there is. And then the last one I'm going to talk about, although there are infinite number of Pythagorean triples, this last one, so again, we have the hypotenuse in one of the legs. So I know that 7 squared plus b squared is going to be 25 squared. So b squared will equal 25 squared minus 17 squared. And I'm just going to let you know that that's going to equal 24 squared. So b is going to equal 24. And this family is known then as a 7, 24, 25 family. That would be sort of your parent part of it. And again, any multiple of that, so if I multiply everything by 2, that would also be a Pythagorean triple. So all of these, and it's basically using your concept of similar triangles, that if you have the same scale factor on the sides, you can get multiple versions of a right triangle. All right, so the families of the Pythagorean triples, and again, these are based on sort of a dilation by the same scale factor. And so the families that you really want to know, just to kind of summarize that, you have the 3, 4, 5 family, you have the 5, 12, 13 family, the 7, 24, 25, there's 8, 15, 17. One I didn't put up there that sometimes appears is 9, 40, 41. And like I said, there's an infinite number of Pythagorean triples. These are the most common. So if you get to recognize them, it really does save you some time. All right. Now, one of the nice things about the Pythagorean theorem is we know it tells us that we have a right triangle. That's actually the converse of your Pythagorean theorem. If the sides satisfy a squared plus b squared, we know we have a right triangle. So a triangle is a right triangle if we know that, and I'm going to now write this c squared, the hypotenuse, equals a squared plus b squared. Now, what if, how could I use the Pythagorean theorem to determine if maybe my triangle is not right, but is acute or obtuse? And what I can do is I can compare it to a right triangle. So what I'm going to do here, and it's really about, I like to look at it in terms of the hypotenuse. It's really all about the hypotenuse. So if you're a right triangle, it would be like this. Now, if I keep these two legs the same length, but I open the angle up, so I'm going to try and keep that side the same length, okay? So I'm going to open it up to there. What happens is, in order to draw what used to be the hypotenuse, what was side C, now notice now when I open that angle up, it has to become longer. So this now is an obtuse angle because it's greater than 90 degrees. So I know I have an obtuse triangle if c squared is greater than a squared plus b squared, because the c in this one is going to be longer than that original hypotenuse. All right, now let's take that same triangle. Let's keep my, I guess I did different colors, okay. So here was my A, my B. We're going to keep these the same length. Here was my hypotenuse. This was a right angle. Well, let's say now what I want to do is I want to bring B in. I'm going to keep it the same length. So it's going to stay the same length. Hopefully I did that at the same length. And my new, it's no longer a hypotenuse, but this is my new C value. Notice that now this angle became acute. It's less than 90. And when that became acute, my C became smaller. So if C squared is less than A squared plus B squared, you have an acute triangle. So that's our goal when you're trying to determine. You'll do basically the template of your Pythagorean theorem, and then it's about whether you are going to be less than, greater than, or equal to, tells you whether it's acute, obtuse, right. And I always like to do it with the potential hypotenuse, that third side first, because we tend to think of acute as small, obtuse as large, and right would be equal. And then you would have the right relationship. All right, so let's try a few examples. I have 4, 4, 4, so I basically have an equilateral triangle. This one you really should just be able to know. If you have an equilateral triangle, all the angles are going to be 60. So it should be acute, but let's use our little strategy to see how this works. So we have 4 squared, and we're comparing it to 4 squared plus 4 squared. So 16 is going to be, we know that's going to be less than 16 plus 16. So that gives me an acute, which is what we thought, because all those angles will be 60 degrees. 4, 6, and 9. So again, it's the longest side that'll always represent, be isolated, I should say. 4 squared plus 6 squared. So on this side we have 81. On this side we have 16 plus 36, which is 52. And since that is greater, 81 is greater, this is going to be an obtuse triangle. Then we have over here, so 4 is my longest side, so 4 squared. How is that related to 2 squared plus 2 rad 3 squared? So this is going to give me 16. On this side I have 4 plus, now when you square something with a radical, you have to distribute the squared, so that's going to be 4 times 3, which is 12. Look at that. So this adds up to 16, so we have ourselves a right triangle. When we get into special triangles, you're going to get to see that hopefully right away as well. And then our last one, so 6 is the longest side. So 6 squared related to 4 squared plus 5 squared, that's 36. This is 16 plus 25 is 41, which is greater than 36. So 36 is less than. Again, we have ourselves another acute triangle. All right, so you have your Pythagorean theorem. Pythagorean triples, which are just really nice to know. You still have your Pythagorean theorem if you're not sure, but as you get to recognize the triples, it saves you a lot of work. And then mainly the new thing here is you can use your Pythagorean theorem to determine whether you have an acute, an obtuse, or a right triangle. That's it.